Hi all. In this presentation, we are going to go through some of the basic concepts about version control systems and a basic introduction to Git concepts and some mostly used Git commands. We will also look at a small practical example of using Git and GitHub for version controlling. So, what is version controlling? It is basically keeping track of the changes to files over time so that if more than one person is working on the same file or project, their changes can be joined without losing anyone's work. Even if one person is working on a project, version controlling is still important to keep track of updates in cases like one wants to roll back to a previous change. Uh, Version control systems are software tools that help us to automate this instead of doing that by ourselves. These are some two main types of version control systems: centralized version control and distributed version control. In the centralized version, one single server stores all of the versions and changes to all files, so the users can take a file, change it, and then push it to the central server. The advantage of this is that the changes are always quickly updated, and no developers will be working on the same thing as everyone adds their changes directly to the main version of the file. This is better for smaller teams, but for larger teams, this can be a bit of a bottleneck. Um, on the other hand, the distributed version control systems, there is a local copy in every developer's computer, and they can add changes to, or do anything locally. And the server only tracks the changes between files, but not physical files for each branch. This is more useful when multiple developers are working on a project and they can work locally in their copies. As we have mentioned earlier as well, there are many benefits of version controlling. It allows history tracking, collaboration, backup and recovery, distributed parallel development, and also it provides the ability to review code. These are some of the popular version control systems. You might have heard of some of them. So Git is the most common version control system among these, and it is a distributed version control system. Mercurial is also a distributed version control system. On the other hand, SVN, TFS, Perforce, and CVS are centralized version control systems. Now let's briefly look at some Git concepts and some tips about how to use Git in your projects. Most of you are probably already familiar with these concepts, so we will quickly go through them. So let's first see what a repository is. A repository is a folder where your Git project and all of its history are stored. If you have a Git project, then the Git repository is the .git folder inside the project. If you delete the .git folder, then you delete your project's history. Git commit is a snapshot of all changes in the working directory. In Git, each commit has a unique identifier called hash. Git branches are basically a pointer to a snapshot of your changes. In other words, branching means you diverge from the main line of development and continue to work without messing with that main line. Merging combines the changes from one branch to another. So if you look at this image, these circles are Git commits, and there are two branches, the main branch and the feature branch. As you can see, so we separately do the development in the feature branch, and then commit our changes and then merge the changes to the main branch. Git checkout is how you navigate between branches you have. So when you check out to a different branch, then that would be where you are actively going to work. Cloning is when you have a Git repository in the server, you make a copy of it in your local machine. So that's what we call cloning. Pushing is uploading your changes that you have done in your cloned local repository to the remote repository. Pulling is simply taking the changes to your local repository, the changes that someone else might have done and push to the remote repository. So by pulling, you update your local repository with the remote changes. Staging is once you have done your changes, you add them to the staging area, and after that you can commit the changes and push them. It is basically preparing your changes before committing. So next we have the Git hosting platforms. So GitHub, GitLab, and Bitbucket are some popular Git hosting platforms. Remember, Git and GitHub are different. Sometimes it can be confusing because we mostly use GitHub to host our Git projects. So you might think that both are the same, but they are not. Um, these hosting platforms offer us ways to collaborate through different ways. We talked about cloning before. Forking creates your own copy of a repository in a remote location. Your own copy means that you will be able to contribute changes to your copy of the repository without affecting the original repository. On the other hand, cloning makes a local copy of a repository, not your own copy. Think of it as downloading a repository onto a local hard drive. Mm. Unlike forks, clones have references to their original repositories. And so next we have pull request. They let you tell others about changes you have pushed to a branch. Once you open a pull request, you can discuss and review your changes with other collaborators and maybe add some follow-up commits before your changes are merged into the base branch. Now let's see some Git tips and best practices. Meaningful commit messages. This might sound easy, but it is not so easy. Your commit message should give an idea to others of what is your changes about, and a good commit message should not be long either. You can add more details as a description, but your message should also be clear and concise. Normally, we use simple present tense like add new method to calculate weight, like that. There can be different practices in different organizations. They might do semantic commits, which means they define not only what you have done, but why you have done. They might specify the type of the commit, like a feature or some general other non-feature related changes. So anyway, the point is to do meaningful commits and commit often. Rather than adding a lot of changes in one commit, it is much easier for everyone if you add only a specific change in one commit. But committing often also does not mean that you should commit every line. Just aim at fulfilling one task in one commit and keep them atomic. Use branches wisely. You can create a new branch to every new feature. Again, different organizations might have their own policies in branching. So okay, now pulling before pushing is a very important thing. Pull before even you start to do the changes, because otherwise you will be spending a lot of time solving merge conflicts or overwriting others' work. And the next one is update to a local repository. So it is like making sure that your copy is up to date. If you have a fork, then update it every time you can with the upstream branch. Interactive rebasing is something like rewriting history. Sometimes it is very useful to know that Git allows you to change your past commits. you can amend the past commits, maybe by changing the commit message or commit the commit changes itself. You can change the order of the commits, or you can squash a few commits. Squashing is when you have multiple commits but you would rather have them together as one commit. Then you can squash them, or you can split the commit to multiple commits. So there are lots of ways to change the past. So interactive rebase allows you to do that interactively, but it is also important to note that when your history is rewritten, it is rewritten. So your all commits will not be the same. For example, if you squashed 5 commits together, you will not be able to go back to an intermediate commit in those 5 commits. So if you are not very familiar with rebasing, I suggest you search and learn about it and also practice using it, because if you know what you are doing, rewriting history and force pushing can be useful things to know. Avoid large binary files, because these files are difficult for Git to manage because the differences between versions is very large. So also every time the file is changed, the repository size will grow by the size of the file. So better to avoid them. And a git ignore file tells Git what it should ignore and not to track. It is a common practice to ignore dependency caches, like node modules or compiled codes, or sometimes your credentials saved in environmental files, which you should not push. And then documentation. Create a good README in your repository. So include a brief overview, setup guide if applicable, maybe use cases, examples, include links, use diagrams and flowcharts, because that would improve the readability and also clarity. So try to maintain a good documentation, especially if it is a public repository. So now we will look at some common Git challenges. Merge conflicts, like I told you before, can be annoying. Sometimes they are unavoidable, but you can resolve them easily using a code editor. And yeah, so the next is accidental commits. Again, they happen, but you can change the past, so you don't need to worry that much about this. And accidental branch deletion, again, you can recover a deleted branch in Git. You can use the command reflog to go to an unreachable commit. So you don't have to remember all the commands. You can search and find them when you need them. Just know that it is possible to recover from your mistakes in Git. Git generally doesn't throw anything away. So a lost commit can be tricky if you force pushed. So the point here is, don't force unless you really mean it. And if you get the message saying that you are in a detached head state, that might be confusing to you at first, but that does not mean that you have done anything wrong. I think you know what Git head is. Head is simply where you are at the moment in your Git repo. So detached head is when head is pointing directly to a commit instead of a branch. So that's just it. And the next one is out of sync with remote. But sometimes when you try to update your fork, you might end up deleting some commits, and then you will panic because your work is gone and replaced by the commits in the remote. But don't worry, you can recover your work. There are Git commands to find lost or dangling commits, so you can recover. But yeah, you should always keep your remote repository in sync with the with the remote with the original repository. So yeah, that's the point of out of sync with remote. And the next one is confusing Git commands. When you are new to Git, even a pull and fetch can be confusing because pull tries to merge automatically. On the other hand, fetch only tries to get the changes but does not merge. uh, there is a git merge and rebase and stash and commit. So these concepts, like, they sound similar but they are different, so these concepts can be confusing, but over time you will get used to it. And now let's go to a small demo where we use some basic git concepts we have just discussed. So I have already created a Git repository, Git demo, and I'm going to use this repository for the rest of my demo. And first, I'm going to use Git commands to create some Git commits and push them. And later, I will also briefly look at how to use the GitHub desktop to do some of the basic Git actions. And okay, so let's first see the git log. So in the repository that I have showed you before, we have these two branches, dev and main, and I have already added this initial commit. And let's see the status. So this is the status of my local repository. So I have added these two files, the demo.java file and this gitignore file. I will show you the content of the files just so you know. So this is what I have added in the gitignore file. So like I have mentioned in the slides, we use the gitignore file when we don't want git to track some certain files. So now because I have not yet added these two files to the staging area, I'm going to add them, and I'm going to add them both. So I'm going to use this tag all instead of adding them one by one. So let's add them, and now let's see the status. And now it says that I have these two files in the staging area, and if I want to unstage them again, I can just simply use this command. So now what I'm going to do is commit them. So and the git commit message. So keep in mind to add some meaningful commit message because right now I don't have that much of feature implemented in those commits, so I don't have a really good commit. But just to show you the change that I have added in the demo file, uh, I will show you the I have to add a cache because now I have staged the file. So yeah, so these are the changes that I have added to the demo.java file. So I will continue on committing the changes. So as the message, I will just add this, like add the class demo. This is not a really good message, but like I have told you, because I don't have that a specific feature or a specific actual atomic chain that I have added to this, I'm just going to do this. Okay, now I have added my changes. Let's see the status again. Yeah, now it says that I have nothing to commit and the working tree is clean. Good. Now let's push this, and when I'm going to push this, there will be some, yeah, now there's this problem that my current branch is not based on the no, it does not it has not yet set the upstream. So if I want to set the upstream, then I have to use this command. So let's use this command, and now my changes are pushed. Now let's see the git log, and now it says that I have these two commits, initial commit and add the class demo. So one thing I would like to mention about this commit messages, like sometimes some people might suggest you to like start the commit message in a capital letter. Sometimes they might say that okay, no, we will follow a message style that will use all the letters as a in simple letters. So anyways, like I have mentioned in the slides as well, the style of the commit messages and the naming conventions of the branches, it may depend from like it may depend on the policies or like the normal practices that different organizations may follow. Okay, so now I have pushed the commits. I would also like to revert this. So now I want to revert the commit that I have just added. Okay, so because I'm going to just revert the last commit, I'm just going to use this, and let's use this. Okay, now it says that this reverse this commit, and I can just if I want to change the message, then I can change the message here, but I don't want to change the message. So let's add this, and now let's see the log, and it says yeah, now it has added this revert at the class demo on top of the commit at the class demo. And one thing I want to emphasize is here I have used the command git revert, and this command git revert is different from git reset, because here notice that this git revert command has added a new commit on top of the previous commit, but in git reset it will be different. So now I will use the command git reset. So let's use git reset, and in git reset you can use two tags, hard or soft. So if you use soft, then that means you will remove the commit, but you will not remove the changes from your local machine. So even though you have removed the commit, you still have your changes. But if you use hard here, then that means you are going to remove the commit including the changes. So because right now I don't mind removing my changes, and because in fact that I want to remove the changes from my local machine as well, I'm going to use hard here. And let's use head, and another thing is I can either use this character tilde, or I can use this character caret. So the difference between those characters is that if I use this character, then that means I'm going backwards, not in a linear way. So to explain it in a better way, the thing is that the git history, so you see this is like the git history, you have some comments made, and this is git history, but this git history is not always linear. So sometimes one git commit might have more than one parent. That can happen when you do a merge commit. So you might end up, one commit might end up having more than one parent, and in that case when you want to go back, so you go to your parent. When you want to go back, what happens is you go back to the parent. So when you have more than one parent, if you use this caret mark, it goes back, like you first go back to the to your first parent, and then the second parent, and then the third parent, like that. But if you use this tilde, it will go in a linear way to your parent, and then your grandparent, and then your grandparent, like that. So this tilde is going backwards in a linear way, while this caret will go back like from a parent to parent. So in my case, it really there is no difference in whether I use caret or the tilde, and anyways I'm going back to one parent, so it doesn't matter which character that I use in my case. So I'm just going to use tilde and go back to the parent, and now I am in this commit at the class daemon. And then so see, now if we look at the git log, now it's like we have the initial commit, and on top of it we have this commit at the class demo. But previously with the revert command, it has added a new commit. So now I think that you might have understood the difference between the commands revert and reset. So now I would like to check out to the main branch. Now I'm in the main branch, and so I will try to create a new branch from the main branch. No, I would before that I would like to merge actually. So because I have added some commits to the dev branch, I would like to merge the dev branch to the main branch. So to merge, we can just use this, and now I'm on the branch main, and if I look at the logs, so in the main branch as well I have these two commits. And now let's create a new branch. Rebase example. So I'm going to create a new branch called rebase example, and now I'm on rebase example, and this branch is made with the main branch. Okay, so what I'm going to do now is do some changes to the demo.java file. So let's just change the method name. Just present rebase. I'm just going to add some name to it, and then yeah, commit it, and then let's see the status. Now I have modified this demo.java file. So let's add this change. Okay, now I'm going to commit these changes. Change the method name. Okay, now let's push these changes. Okay, now in the rebase example, I have a git log. I have added this new commit, change the method name, and I'm going to check out to main, and I'm going to merge this new branch rebase example to the main. So now in main I might have all these new commits. Yeah, so in the main branch I have these new commits. So next what I'm going to do is I'm going to check out to the dev branch, And as you can, maybe you will remember that in the dev branch I only have these two commits. So I'm going to create a new branch, git checkout branch merge conflict. The branch name is merge conflict. Let's say example, and I'm going to create this branch from the dev branch, and now I'm in the merge conflict x branch, and now I'm going to change the demoted Java again. So here let's see present merge conflict. Okay, and let's give demo.java, and let's see the status. So I have added this. Now let's commit this. And let's push it. And then let's try to rebase main here. And now we've got some merge conflicts. That's because we have added some changes to the demoted Java from the previous branch, a rebase example branch. So, and at the same time, I have added some changes to the demoted Java from the branch merge conflict 6. So now let's solve this merge conflict. Let's see our file, and let's keep the second one, that is the merge conflict, present merge conflict, because that's what we are going to do. So let's solve the merge conflicts by removing them. So there are actually, I mean, if you use some code editors like IntelliJ or VS Code, then these solving these merge conflicts are pretty easy. But right now I'm just not going to do that because this is straightforward for me in this case. So let's yeah, now let's use git add, and we will continue. And so I'm going to I'm going to keep this commit message, and let's do this. Now let's see the git logs. Okay, now we have like solve the merge conflict. We can also see the now in the rebase you can see that the new commit is on top of the previous commit that we have added to the main branch. So if you can remember, I have first added this commit to the rebase example, this change method name, and then I created a new branch from the dev branch called the merge conflict x, and then for that I added a new commit, and then I rebased. And when I rebased, I have added this new commit that I added to the merge conflict text on top of the commits that I have added to the main branch. Okay, and next let's look at briefly look at how we can do these things in the GitHub desktop. But things are pretty straightforward actually in GitHub desktop. So if you want to change the branch, then you can simply just select the branch that you would like to check out to, and then yeah, you will be checked out. And if you can just simply check the history here. In this, you can view what are the changes that is done in each of these commits. And if you have any changes locally, then they will be displayed here, so you can just add the commit message and then commit. So pushing a commit is also very easy here. Also, if you want to update your branch from main, so right now I'm in merge conflict text, and if I want to update it from the main branch, then I can just select this. I can compare to a branch. Let's compare this with the main branch, and it says that okay, this branch merge conflict text is ahead one commit from the main branch, and the commit is this change of the method name. And also we can rebase from this by selecting that, and then you can select the branch that you want to rebase. And that's how you rebase. And if you want to squash, so if you want to squash, let's see, so let's say that you want to squash these two commits. So I have talked about squashing before. In the command line, if you want to squash two commits, then what you can do is use that command git reset soft. So as I think you can remember that when we use the git reset soft, what it does is it keeps the changes in your local repository, but it like removes the commits. So now that you have these changes locally, you can create a new commit and then force push it. So then you will have one commit instead of those two commits. So here what you can do is you can just uh, select squash two commits rather than using those commands. You can simply squash it here. And you can also cherry pick. I haven't talked about cherry picking before. So cherry pick is you just select one commit like this, and you are going to select some branch that you are going to apply this commit to, and then after you select this branch, this selected commit will be applied to the branch that you select. uh, so there is a command as well for cherry pick. So that's also like similar to this. You just select the commit hash and then use the git cherry pick the commit hash. And yeah, so if you can pull and push here. So that's about it. And there are lots of other tools actually which can be pretty useful when you first try to learn Git. These tools can be pretty useful and easy to use. So and this is the end of the demo, and I hope that you got some basic idea about Git commands, how to use them in your projects. And yeah, so let's go back to the presentation. So, as for the conclusion of what we have talked up to now, version control systems are very useful to collaborate and maintain code history. Git is the most widely used version control system. We also discussed some basic Git concepts, best practices, and some challenges. So I hope you got some basic idea about version controlling. And yeah, so these are some useful links to learn about Git. Some of them are interactive and quite fun, like Oh My Git and GitHub Minesweeper. I would suggest you check them out if you want to learn more on Git. And yeah, this is the end of the video, and thank you for watching.